When you think tsunami, you probably picture a massive earthquake deep under the ocean, right? But what if that's not the whole story? Turns out scientists recently picked up a signal so bizarre it's completely rewriting our understanding of these giant waves and revealing a new kind of threat that's been hiding in plain sight.
So, it all kicked off with this incredible mystery. All around the world, seismometers started detecting this strange, constant vibration. It wasn't the sudden jolt of an earthquake, it was this low, steady hum that just kept going. For 9 straight days. Geologists were completely baffled.
And this wasn't just a small puzzle. The entire scientific community was stumped. Top seismologists like Stephen Hicks at University College London flat out called it completely unprecedented. Nothing they'd ever seen could explain a vibration like this, one that could go on for so long and travel so far. The hunt for whatever was causing it was officially on.
And it took a massive effort to find it. We're talking about an international team of 68 scientists using everything they had: satellite pictures, seismic data, you name it. And they finally pinpointed the source, a remote, steep-walled inlet in eastern Greenland called Dixon Fjord. But what on earth happened there? Well, what they found wasn't a tectonic plate slipping. It was a terrifying chain reaction. First, you have our warming climate melting a glacier that was basically acting like a doorstop, holding up the side of a mountain. With that ice gone, the mountainside became incredibly unstable. And then, a colossal chunk of rock and ice, 25 million cubic meters of it, just collapsed into the fjord, creating a mega-tsunami. And believe me, mega-tsunami is not an exaggeration. The very first wave was a staggering 650 feet high. Just to give you a sense of scale, that is taller than the Washington Monument. It's one of the highest tsunami waves ever recorded. But here's the thing. That giant initial splash doesn't explain why the hum lasted for 9 days. For that, we have to look at the unique shape of the fjord itself. The phenomenon behind that long-lasting hum is something called a seiche. The easiest way to picture it is to think about water sloshing back and forth in a bathtub. That giant tsunami wave got trapped inside the steep, narrow walls of the fjord, so it just kept bouncing from one side to the other over and over again, creating that steady, rhythmic vibration that seismometers picked up thousands of miles away. And this discovery absolutely changed everything. One of the study's authors, Christian Svenevig, basically said that if he'd suggested a year ago that a siege could last for 9 days, other scientists would have thought he was crazy. They would have said it was impossible. This one event in Greenland literally rewrote the geology textbooks. So here's the really crucial part. This wasn't just some wild, one-off spectacle of nature. Scientists are now looking at this as a serious warning shot, because the same conditions that caused that Greenland mega-tsunami, well, they exist in other places around the world. And it turns out, this has happened before, hidden deep in our planet's past. Let's jump to the other side of the planet for a second, to Antarctica. Scientists there drilled deep into the seabed and found something really interesting. Layers of weak, loose sediment left over from past warm periods, millions of years ago. During those ancient warm spells, these layers collapsed, causing huge underwater landslides and, you guessed it, tsunamis. And now, as our climate warms, those same exact conditions are starting to come back. So you might be wondering, how does melting ice cause an earthquake? It's a wild process called isostatic rebound. Think about it like this. Press your hand down on a soft pillow, and then lift it up. The pillow springs back, right? Well, it's the same idea, just on a planetary scale. As these enormous ice sheets melt, that incredible weight is lifted off the Earth's crust, and the crust actually bounces back up. That movement can destabilize tectonic faults and trigger earthquakes, which can then shake those unstable underwater slopes loose. And look, this isn't just a theory or something that happened millions of years ago. We have a truly devastating example from human history of what happens when one of these underwater landslides lets go. We're going to talk about the Storegga slide, which happened off the coast of Norway about 8,200 years ago. The scale of this thing is just mind-boggling. An estimated 3,500 cubic kilometers of debris collapsed off the continental shelf. To try and put that into perspective, that is enough material to cover the entire country of Iceland in a layer of rock and mud over 100 feet thick. It's almost impossible to imagine. And the tsunami it created was catastrophic for the people living back then. It completely submerged Doggerland. That was a land bridge that actually connected Britain to mainland Europe. Gone. In what's now Scotland, the wave traveled 18 miles inland. Archaeologists are pretty sure it just wiped out entire coastal communities and might have killed up to a quarter of Britain's entire population at the time.
It was a civilization-altering event.
Okay, so we've got this new threat from melting ice, and we've got history telling us just how devastating it can be. But what if I told you there's one more critical piece to this puzzle? What if the very tools we use to predict tsunami risk are fundamentally flawed and are actually making us underestimate the danger?
See, most current hazard plans use what's called a static model, or a bathtub model. It's super simple. You just raise the sea level on a map that never changes. But coastlines do change, right? And that's where a new, much more realistic approach comes in, the dynamic model. It actually accounts for how coastlines evolve, how marshes and barrier islands shift around in response to climate change.
And this, right here, is the key finding. The dynamic model shows that as these coastlines change their geography, they can act like a funnel. Their new shape can channel and dramatically amplify an incoming tsunami wave, making its impact far, far worse than the simple bathtub model would ever predict.
So, how much worse are we talking? The results are genuinely shocking. This new research shows that the actual tsunami hazard could be up to 3 times larger than what our current standard models are telling us. 3 times! We could be under-preparing for this danger by a huge margin.
And that brings us right back to where we started, with that weird hum from Greenland. As landslide modeler Anne Mangini puts it, the seismic vibrations from that one event traveled from Greenland all the way to Antarctica in less than an hour. It's just a stark reminder that a climate change event in one remote corner of the world can have immediate, planet-wide effects.
So, in the end, that 9-day hum wasn't just some geological curiosity. It was a message. It was a wake-up call that revealed a whole new kind of tsunami threat, linked it directly to our past, and showed us that our methods for predicting the future might be dangerously out of date. It leaves us with a pretty critical question. As the Great Thaw continues, what other sleeping giants are out there just waiting to be woken up?